Welcome back. This is CHEM300. We're continuing chapter 3, now talking about physical and chemical changes of matter. So this lecture goes hand in hand with the previous one that was on physical and chemical properties of matter. A change is like the process, like the action, and then the property is like what's observed through that action. And so again, they go hand in hand. To see a physical property, you have to undergo a physical change. And to see a chemical property, you have to observe a chemical change. So that's why they go hand in hand. So let's talk about them. So matter can be described based on the physical and chemical changes associated with that matter. So a physical change is a change in which no chemical bonds are broken or formed. The substance retains its identity during a physical change. It might change states from like a liquid to a solid or from a gas to a liquid, but it's not changing its identity during a physical change. Versus in a chemical change, these are changes that occur when chemical bonds are broken or formed between molecules and atoms. So when a chemical change happens, you're going to have different substances present after the change. The original substance is going to undergo some chemical reaction, bonds are going to be broken or made, and then you end up with something new at the end. So some examples of physical changes. Changes of state, like when things change from a solid to a liquid or a gas or vice versa. Changes of state are physical changes. Separating a mixture, that's a physical change. Taking two substances and just physically separating them, you still have the same two substances when you're done. The only thing that's changed is that instead of being mixed together, they're no longer mixed. Physical deformation, like cutting, denting, stretching, it doesn't change the identity of the substance, you're just changing its shape. And then making solutions. When you make a solution, you don't change the identity of what's going into the solution. It's just a special type of mixture where everything is so well blended together. It's homogeneous and you can no longer separate the phases just by letting them settle. Okay, so some examples of chemical changes. In chemical changes, these are the changes that happen when there's a chemical reaction happening, when bonds are being broken or new bonds are being formed. And because we can't actually see the breaking and forming of chemical bonds, right? It's happening at such a small scale, we can't directly observe like a bond separating and then a new bond being made. We have to look for signs that a chemical change is happening. So the signs we look for that indicate that, hey, we might have a chemical change happening here, is we look for changes in temperature, right? If you put two substances together and when you mix them, it starts heating up or cooling down, that's a sign that there's a chemical change happening, that there's some chemistry going on where some bonds are being broken and some new bonds are being made to make some new substances. When bubbles form, you mix two things together like baking soda and vinegar. If you've ever made like a homemade volcano, you get those bubbles forming to make the volcano lava. That's a chemical reaction. It's a chemical change. The two things you mix together are breaking bonds and making new bonds to make a new substance at the end. One of those new substances is carbon dioxide, and that's how you get all the bubbles when you make one of those homemade volcanoes with baking soda and vinegar. If a precipitate forms, precipitate is when a solid forms inside a liquid solution. So you have two substances in the liquid phase mixed together, and then they react, they undergo a chemical change, and the result of that chemical change is a solid being made inside the solution. And so when you mix two things together that undergo this type of chemical change, you'll be watching the solution and suddenly bits of solid start showing up inside it. And oftentimes you'll start with a clear solution, and then as the solid starts to be made, it starts to turn cloudy, and you might see little like flakes of the solid start to float around inside it. Other examples of chemical changes, things we look for, if something gives off light, that's a good sign that there's a chemical change happening. If you get a new taste or a new smell. So we said that physical changes is like the odor of something. That's just like the natural odor of like just gasoline. But when you burn gasoline, you get a very different odor given off, right? You smell the smoke and that like putrid kind of carbon dioxide smell. That's that new smell that's given off when a chemical change happens when you burn gasoline. But just gasoline sitting, that also has an odor. That's a physical property. Burning the gasoline, giving off a very distinct different smell, that's a chemical property or a chemical change. And then if you make a totally new color, one that's not just made by like mixing two colored solutions together, but a just totally new color is made, that can also be an indication that there's a chemical change happening. So these are fun. These are fun to watch in the lab, right? Monitoring temperature, checking for bubbles, looking in solutions to see if it starts getting cloudy, making things glow by doing chemical reactions, making things smell by doing chemical reactions, or making really fun new colors. These are all examples of chemical changes that we look for to indicate that we're breaking some chemical bonds, making new bonds to make new substances. So chemical properties, which we talked about in the previous lecture, those arise from chemical changes. Something has to undergo a chemical change to kind of like show us the chemical property. So rusting is a chemical change. When iron rusts, it turns from iron into iron oxide. So here we have some non-rusted iron, chemical symbol Fe, a nice clean nail. When iron is exposed to oxygen, which is contained in the air, so when iron is exposed to air, over time, the iron and the oxygen are going to react to make iron oxide. And iron oxide is what we call rust. So there's a chemical change happening. We're starting out with iron plus oxygen, and we're making a new substance, iron 3 oxide, rust. So we have iron atoms, oxygen atoms, and we end up with a compound, iron 3 oxide. So this chemical change, iron and oxygen turning into iron oxide, shows us the property of rusting. To give you another example, oxidation of copper is a chemical change. So the Statue of Liberty was made out of copper in 1886. It was this shiny copper color, which is hard for me to imagine nowadays, right? Shiny, beautiful, like a new copper penny. But over time, copper will react with the oxygen and air to oxidize. It undergoes a chemical change. And so over time, the Statue of Liberty went from looking like a shiny new penny to this green oxidized copper look that we're familiar with today. So this copper turning green in air, that's a chemical property. It's showing us the chemical change of oxidation by changing color dramatically. And that's what I mean by like a totally different color. So to see a chemical property, something has to undergo a chemical change. And that's what I was talking about last time when I said these two lectures are directly related. Properties and changes, whether they're physical or chemical, they always go hand in hand. You observe the property by watching the change. So when matter undergoes a chemical change, that means it's undergoing a chemical reaction. In a chemical reaction, the substances that are present before the chemical change are called the reactants. We always write those on the left side, shown here. That's what you start with. And then the substance undergoes a chemical change, and we show that with this arrow. The arrow means that there's a chemical change happening. Chemical bonds are being broken, new bonds are being made. And when things reshuffle, the atoms reshuffle and they come together in a new way, you make new substances called the products. New substances, and this is your starting. So this is how we diagram out chemical reactions. You start with the reactants. Could be one thing, could be multiple things coming together, atoms or molecules. They undergo a chemical change, and then new things are made, which we call the products. So let's give some examples. So a lighter, like a flick lighter, is a really good example of matter undergoing physical and chemical changes. So if you push the button on a lighter without turning the flint, right, you have the button, and then you have to turn that like metal circle to get it to spark. That's the flint. If you push the button without turning the flint, inside you have liquid butane. That's like the substance that's going to eventually combust and make the flame. And when you push the button, it releases some of the pressure inside the lighter. And so this liquid butane turns into gaseous butane. So it changes phases. That's a physical change. A liquid going into a gas, it's still butane. The only thing that's changed is its physical state. So this is an example of a physical change. But if you push the button and turn the flint to create that spark, you're going to produce a flame. And so this is going to produce a chemical change. Liquid butane, your starting material, butane. See if I can write an E properly. Undergoes a chemical change to become carbon dioxide plus water. And then we have to make the flame, so we're going to produce some heat in that reaction as well. But you can see, right, you start with something, butane, and at the end of this change, you have different substances present. So that's a chemical change that's happening. Just releasing the butane from the liquid state to the gas state, not a chemical change, it's still butane. But when it undergoes this chemical change by combusting, by being burned in the presence of oxygen, it undergoes a chemical change. And we see its property of flammability, that it's able to undergo that chemical change by combusting. It's highly flammable. So here's a summary of physical and chemical properties and changes. So you have everything physical on the left side, everything chemical on the right. So the term physical conveys the idea that the composition, the chemical identity of a substance does not change. So we have physical properties, properties that are observable without changing composition, like color, shape, physical state, boiling and melting points. Physical changes are changes that are observable without changing the composition. So changing state, changing, the state of subdivision, like if you have a cube of sugar and you break it up into a bunch of little tiny grains of sugar, it's still sugar. The composition didn't change, you just changed its physical like subdivision. Then on the chemical side, chemical, this term conveys the idea that the composition, the chemical identity of a substance does change. So chemical changes are changes in which one or more new substances are formed. These happen during chemical reactions. And then chemical properties, these are the properties that describe how a substance changes to form a new substance. So flammability, decomposition, if something can break down into simpler substances, if it reacts with certain things, those are all chemical properties. It's very, very common to separate mixtures by physical changes, to use physical changes as a method to, say, purify or separate out a mixture. So your textbook talks about this just a little bit towards the end of this section. But it's something we use all the time, especially commercially, to make a lot of the products that you may be familiar with. So a homogeneous mixture solution can be separated into its component substances using physical properties that rely on, using physical processes that rely on some physical property. So for example, steam distillation. That's a physical process where you use the difference in boiling points of a mixture of substances to separate that mixture. So let's say you have water and hexane, they're mixed together. Hexane has a much lower boiling point than water, so you could heat the substance up and perform steam distillation because hexane is going to boil at a lower temperature. It would turn into vapor. You could collect that, and then you can keep heating it, and then eventually the water would also vaporize and you could collect that. So it's a method of separating a mixture by having the components of that mixture undergo a physical change. And because they're going to undergo these physical changes at different times or different temperatures, you can use that to separate out that mixture. Another really common one is crystallization. Crystallization depends on the physical property of solubility. So different substances can dissolve better or worse in water compared to one another. So this is used a lot in candy making. Sucrose, depending on the temperature of the water it's dissolved in, can be very soluble. It's very soluble in hot water, but in cold water, sucrose, sugar, is not as soluble. So a lot of techniques for making candy, especially if you've ever had rock candy, you make a solution in hot water that has a whole bunch of sugar dissolved in it, and then you cool the solution. And as the solution cools, the sugar is no longer soluble. It'll crystallize out and you can make these really neat candy crystal shapes. Now, this is also used in the pharmaceutical industry to crystallize out and like purify different substances used in making pharmaceuticals and different drugs that people take for medicine. Another one is density gradients, because density is a physical property. You can separate things out by their density. I did this a lot when I was doing research. I studied mitochondria. And so in order to study the mitochondria, I had to separate out the mitochondria from the rest of the cell. And so I would use density in order to do that. Mitochondria have a different density than other components and organelles within the cell, like the endoplasmic reticulum and the nucleus and the different parts. So I would use the density of the mitochondria to separate the mitochondria out from everything else. And the last one is filtration. This is filtering substances. If you make coffee the old-fashioned way by brewing it, you filter, you put the coffee grounds on top of the filter paper, you run water through it, and then you retain the coffee grounds on top of the paper and the water goes through with the coffee flavors in it. That's a physical separation, separating based on phase. The solid phase stays on top of the paper, the liquid phase goes through. Coffee. This is an example of a chemistry lab distillation setup. Distillation is used to separate mixtures based on the boiling points of the different components of the mixture. Distillation is used a lot in the brewing and spirits and alcohol industry, right? To make sure that the beverage is very, very pure, it'll be distilled multiple times. What they do is, right, you put your solution that has the mixture in it in the bottom of a flask, you heat it, and substance one might turn into a gas. First, it goes up into this column, collects here, and you have cold water running around this tube. Cool water in, warm water out. And so the gas goes up, it hits this tube, and then as it gets close to the cold water, it goes from a gas back into a liquid. And then it will drip down and you can collect it over here. And if your substances of your mixture turn into a gas at different temperatures, then as you heat this up, the first one will turn into a gas, you can collect it. Then the second one will turn into a gas, you can collect it, and so forth. And so this is used all the time in different, especially food and beverage industries, to get things really pure. Okay, so that's the end of our discussion on physical and chemical properties and physical and chemical changes. Again, they go hand in hand. The change happens and then you observe the property. So our next section is going to be on conservation of mass. We'll pick it up there next time. Thanks.